Good evening, ladies and gentlemen. Welcome to Text Messages of the Resurrection. We thank you for joining us once again. It's Friday evening, February 8th, 2019. It's very, very cold outside. We got about 15 below Fahrenheit for the highs. Well, actually, the high was about -3 below. And the low will be probably about -15. So it's definitely one of those temperatures where you go outside and it just feels like the wind is blowing your face the whole time, when in reality, there happens to be no wind at all. It just feels that greater pain, suffering. But pain and suffering are ultimately what builds character, and characters are what builds societies. So we're not exactly too worried about dealing with that here and there. Now, as you can tell, ladies and gentlemen, we have a microphone. We also have a deviation of sound. Approximately about 8 months ago, when the show was first getting sponsored, I spent an enormous amount of cash on this microphone, a Blue Yeti Pro version, not cheap crap here. When we spend money on stuff for Text Messages of the Resurrection, we try to go above and beyond the call of duty. They got a Blue Yeti Pro. Now, initially the plan was to hook it up to the camera, the insanely expensive camera, which has a 3.5mm input jack. Unfortunately, we had an XLR to 3.5mm converter and it didn't quite work because the microphone is supposed to be independently powered, which this one is USB powered, so it doesn't quite work that way. But what you also may have noticed is that the synchronization of the video and sound is not very good. Fortunately, we will correct that sometime in the near future, because essentially what we have to do is get an Elgato BM or a cam link, which is basically a USB on one end, HDMI on the other, and then that'll hook up with the insanely expensive camera. So the insanely expensive camera has a Type-C HDMI connection. That'll hook up to the Type-A on the Elgato cam link, and then the cam link will hook up through the USB to the computer. And then the computer and the microphone will both be in sync, recording through OBS Studio. So ultimately, that's the plan. We still got to get the Elgato hardware, but for the foreseeable future, we believe that that'll be a structured and hopefully a prudent approach to creating Text Messages of the Resurrection at a very high level. Hell, we might have to start calling it the new and improved Text Messages, the Resurrection. So it might get to the point where just the name of the show will take up a vast quantity of all the speaking, but hopefully we don't get to that point. Certainly it'd be disrespectful for you, ladies and gentlemen, to just come up with a elongated moniker for the show, especially because generally we want to try to improve the quality of the content as well. See, that's the thing. The last couple days of the shows haven't really been up to par as far as content quality. One of the reasons why is because I've just been laser focused on getting the hardware up to spec. You may not have been able to notice it at all, but we were experimenting with a lot of things like memory foam, sound suppressants, echo reduction, and all things of that nature. And for video, we were just experimenting with different qualities so that we could edit it better. But what we're probably going to have to do is get some fancy hardware. Maybe one of those big computers that video gamers use or something like that, which would probably work good for video editing. So we'll look into that too. Just try to get all of our ducks in order as far as the hardware of the show goes. And then we can worry about the quality of the content of the character. Judge a show not by the quality of its content, but by the quality of its hardware is really not what anybody said. So now what we wanted to get into tonight, ladies and gentlemen. Now, we talked about white blood cells a couple weeks back. So when you look at the human blood, it has white blood cells, red blood cells, platelets, and then the plasma that transports it. Now, white blood cells are only about 1%, but they are very important. They eradicate disease, pathogens, bacteria, viruses, and they get rid of waste material as well. They phagocytosis. Essentially, they're like Pac-Man. They go and eat up all the dead and dormant material that's no longer needed in the body, and then the rest of the blood ships it out in the plasma. So the red blood cells. Now, if you've ever seen a microscope, in fact, actually, you can look at our green screen here. This is essentially what the red blood cells look like. They're just little discs. They look like a donut, except they have a center. An indented center, I guess you could call it. So what their primary function is they carry fresh oxygen through the body. Now they get the oxygen through the lungs. So when you breathe in the gases, the lungs and nitrogen and everything, or breathe in the oxygen and the nitrogen and whatever else is in the air, maybe some cyanide or Zyklon B and all that kind of stuff. So the hemoglobin within your red blood cells carry the oxygen. They carry it to all the body parts that need it. And then it takes the carbon dioxide and then carries it out and puts it back into the lungs, and then you exhale. So you inhale oxygen, exhale carbon dioxide. Plants inhale carbon dioxide, exhale oxygen. Now, yeah, plants will respirate too, and they will exhale oxygen at some point. But by and large, as a greater ratio, they exhale more oxygen than they inhale. Now, red blood cells are created in the bone marrow. You may have heard of bone broth before. See, that's why bone broth is so healthy, because your bones are a living tissue. So when you eat bones of other animals, so long as you slow cook it inside apple cider vinegar for a while, you're actually getting a deluge of very, very healthy nutrients, or at least nutrients that'll help you. And these typically last about 120 days. Some of the vitamins that help, vitamins B and E along with iron, contribute to the health of the red blood cells. So you can generally get vitamin B from meats, and vitamin E you can get it from tree nuts. Iron, you can get that from clean sources of water. Dark chocolate actually has a lot of iron in it. Just anything grown in the ground in healthy soil is likely going to uptake some iron as a mineral. Now, the red blood cells are about 6 to 8 micrometers in diameter. At any given time, you have about 20 to 30 trillion of them in your body. And yeah, they're roughly 40 to 45% of the blood's volume. Probably about 50% is the plasma, and 5% might be platelets, and then the 1% white blood cells. So the red blood cells are pretty prevalent, and they're usually called red because when you expose them to the oxygen, then they become red to the atmosphere. So when you look at your veins, if your skin is translucent, they look like they're blue. But when you get cut, then your blood is red. So yeah, once they're exposed to oxygen, then that's usually what happens. So 6 to 8 micrometers in diameter. If you had an optical microscope with 1,000 or 2,500 times microscopic power, you would be able to see these platelets. In fact, this is probably an optical microscope. This might actually be either a scanning microscope or an atomic force one, which they can magnify far greater because they don't have all the reflective or the concavities or whatever inherent difficulties are with optical microscopes. No, you may have heard of anemia, which is when you have too low of red blood cells, or they're deformed or anything, or you have enough but they just aren't able to carry oxygen as efficiently as they should. Say for example, if you have low iron in your blood, then you may have anemia, because essentially your red blood cells need that to carry all the oxygen around. And your spleen acts as a reservoir. A lot of times if you go jogging or running, you may feel a weird pain in your side. And that's usually because your spleen is just squeezing and pushing out as much blood as it can possibly can and trying to produce the red blood cells, and it's working hard. It's just one of them things that it feels the pain. So, at any given time, your body has approximately 2.5 grams of iron. Now, the membrane of the red blood cells has 3 layers. The glycocalyx is on the exterior. That happens to be rich in carbohydrates. Now, if you are eating a ketogenic diet, your body can synthesize a lot of these glucoses and carbohydrates, so you don't need to worry too much about it. I mean, in fact, a fat cell is just an extension of a carbohydrate or a protein. But I mean, fat doesn't convert to protein. There are essential proteins and there are essential fatty acids. But carbohydrates, by and large, can be synthesized within your body. So the other layer is the lipid bilayer, which is a transmembrane that consists of proteins. And then there's a skeleton, which is a structural network of proteins. So half of the mass of the red blood cells are protein, and then the other half are phospholipids and cholesterol. See, the phospholipids are the fatty acids, and the cholesterol is biosynthesized in your body. I mean, yeah, it has the same products as the cholesterol that you could find in an egg yolk, but it's essentially created by your own body. Now, when you hear about high cholesterol, one of the hypotheses of that is that if you eat a lot of trans fatty acids or just sugar or things that put abrasion in your blood arteries and veins, what's going to happen is when they start scarring, the cholesterol is what tries to repair them. So if you have high cholesterol, it's not the cholesterol that's bad, it's the agents causing all the scarring and the abrasions within your veins and your arteries and capillaries and all that stuff too. So red blood cells are actually very flexible. They can compress and squeeze through capillaries less than half of its diameter. And it's believed that hydrogen sulfide, which is derived from garlic, helps with that malleability. I mean, garlic just has a plethora of health benefits that go along with it. Same with ginger and taro root and turmeric. You can find them at any grocery store. They're usually probably in the produce section. You know, you just buy the bare root, toss it in a bag, and bring it to the checkout and type in root on the self-checkout, and then you're good to go. It'll weigh it too, so you got to make sure you're not scamming the weight system. So the secondary function of the red blood cells is it releases ATP adenotriphosphates, S-nitrosothanols, and synthesizes nitric oxide using L-arginine. Now, you may have heard of some of those terms before through people that use creatine monohydrate. So creatine essentially does a lot of that same stuff too. It's basically, creatine is actually found naturally in red meat, cow meat and all that, and beef and everything. So it can increase blood flow to areas of stress, which is if you're lifting weights or if you have a cut or in a very wide abrasion, or if you hit your thumb on a grinder, it will increase the blood flow to that. So when it's lysed or broken down by pathogens, the red blood cells release free radicals to break the cell wall and kill it. So the red blood cells actually, along with the white blood cells, they will attack pathogens as well. So if a pathogen tries to attack a red blood cell, it'll essentially just go after it and break it down and try to kill it. So that's essentially what red blood cells do. They carry oxygen and carbon dioxide. They release adenotriphosphates, nitric oxide, and they squeeze into your capillaries. Now, if you've heard about arteries and veins, the difference is blood is pushed in arteries and it's pulled in veins. So your heart is, when your heart beats, it's pushing and then it's pulling. It's like when you get a rubber tube or a desolder. It's that little rubber, it looks like just basically a rubber ball. So when you push it, it goes out. When you release it, it squeezes back in. So your heart is doing work on both ends of the spectrum there. The arteries, it's being pushed, the veins is being pulled. Now you can also get blood counts. You probably heard of blood counts if you've ever been to a hospital before. One of the ways you can do them at home though is you can get a hemocytometer, which can count your red blood cells. It's got like these 9 grids on it, and then you just get a sampling size. You get a magnification, an optical microscope will work, 1,000 times magnification, whatever. It'll have a specific number based on your hemocytometer, what magnification you're supposed to use, and then you can count the number of red blood cells in certain grids, and then you in a Neubauer counting chamber, and then with that you can figure out just pretty approximately close to accurate how many red blood cells you have relative to other cells in your blood. So with that being said, ladies and gentlemen, we're going to have to put a wrap on this show. We appreciate you joining us and bearing with us as we experiment with some of our new technology, and hopefully the show from a hardware standpoint will be great soon, and from the quality, we're hoping the quality will just cascade along with the hardware. So thank you very much, ladies and gentlemen.